There's a dirty secret in enterprise AI deployments that nobody wants to put in a post-mortem. The more documents you feed your RAG system, the worse it can actually perform. This isn't a model limitation. It's a fundamental mathematical property of high-dimensional space that catches teams completely off guard after they've already celebrated their launch. In high-dimensional vector space, something counterintuitive happens as your document count grows into the tens of thousands. The mathematical distances between vectors begin to compress. Everything starts appearing equally close to everything else. Your nearest neighbor search, which worked brilliantly at a few hundred documents, begins returning noise with complete statistical confidence. It's not guessing randomly, it's confidently wrong, which is actually worse. The failure mode here is insidious because it doesn't crash your system. It just makes answers progressively mushier. A team builds a RAG pipeline. It performs beautifully in testing with a few hundred documents. They ship it, they onboard the full knowledge base, and then quietly, over days and weeks, the answers get worse. Nobody files a bug report because it's hard to quantify. So they upgrade to GPT-4. Still mushy. They add more documents. Now it's measurably worse. The retrieval step was the culprit the entire time. One of the most underutilized fixes is also one of the most proven: hybrid search. Combining classic BM25 keyword retrieval with modern semantic vector search consistently outperforms either approach used in isolation, especially on large corpora. BM25 excels at precise term matching, exact product names, technical identifiers, proper nouns, while semantic search handles conceptual similarity. Together they cover each other's blind spots in ways that repeatedly surprise teams who assumed semantic search had made keyword search obsolete. If there's one technique that delivers the highest return on engineering investment in RAG systems, it's cross-encoder re-ranking after initial retrieval. The strategy is straightforward. Use your vector search to retrieve a broad candidate set of perhaps 20 documents, then run a cross-encoder model that scores each candidate directly against the original query in full context, and pass only the top 3 results to your language model. Cross-encoders are slower than bi-encoders, but dramatically more accurate because they evaluate query and document together rather than independently, catching relevance signals that embedding-based retrieval simply cannot see. Hierarchical indexing addresses the curse of dimensionality by structuring the retrieval problem differently from the ground up. Instead of a single flat vector store where every document competes equally, you build a coarse layer, perhaps indexed by topic, department, or document type, and a fine layer of granular chunks within those categories. Retrieval first narrows the search space at the coarse level before performing similarity search within a much smaller, more coherent subset. This approach mirrors how humans actually navigate large knowledge bases, category first, then specifics. For teams operating at serious scale, Colbert-style late interaction retrieval represents a fundamentally different architectural approach worth understanding. Traditional dense retrieval collapses an entire document into a single vector, inevitably losing token-level nuance in that compression. Colbert instead stores embeddings for every individual token and computes relevance through interaction between query tokens and document tokens at retrieval time. This preservation of fine-grained detail becomes increasingly valuable as document length and corpus size grow, addressing the exact information collapse that makes large flat vector stores unreliable. The core insight is this: RAG as a paradigm is not broken, but the widespread assumption that retrieval is a solved problem is genuinely broken. If your AI system gets dumber as you feed it more data, you have a retrieval engineering problem, not a model problem. Swapping in a larger or newer language model cannot compensate for a retrieval layer returning the wrong context. The solutions, hybrid search, re-ranking, hierarchical indexing, late interaction, are not exotic research concepts. They are established engineering techniques that get systematically skipped in the rush to ship. Unglamorous retrieval engineering is where production RAG performance is actually won or lost.